What if I told you coding is no longer the valuable skill you think it is? Not because it's useless, but because it's becoming common. And when something becomes common, it becomes cheap. Right now, a massive shift is happening. The labor premium, the real money, the real power, is moving upward. It's no longer for people who just write code. It's going to those who can design, integrate, and fix systems when everything breaks. And everyone else? They risk becoming replaceable. For years, software engineering was one of the most valuable careers in the world. If you could code, you were in demand. Companies needed you, salaries went up, opportunities were everywhere. But today, things are changing fast. AI can now write code. It can generate apps, fix bugs, and even build entire systems from prompts. So what happens when everyone has access to that power? Simple. The value of basic coding drops. Think about it like this. There was a time when knowing how to use a computer made you special. Now, everyone does. Coding is heading in the same direction. We're entering a world where many developers are doing the same thing, using tools, frameworks, and AI to assemble solutions, without fully understanding how they work. And that creates a dangerous situation, because when your skill is just assembling pieces, you can be replaced by someone faster, cheaper, or by AI itself. This is what economists call commoditization. When a skill becomes standardized and widely available, it loses its uniqueness and its value. That's why the middle of software engineering is shrinking. Not beginners, not experts. The middle. Now here's the good news. Not everything is being replaced. Some skills are becoming more valuable than ever. Let's break them down. 1. Systems and architecture. When things break, and they will break, AI doesn't understand the deeper layers. It doesn't truly grasp how memory, networks, and hardware interact under pressure. That's where humans come in. People who understand systems at a deep level, who can diagnose failures, design resilient architectures, and think beyond code. They will always be needed, because when abstractions fail, only understanding remains. 2. Cross-disciplinary integration. The future isn't just software, it's software plus energy, software plus biology, software plus manufacturing, software plus space. And each of these fields has real-world constraints: physics, materials, safety, time, cost. AI can write code, but it doesn't live in the real world. People who can bridge these domains, who understand both code and physical systems, will become extremely valuable. 3. Accountability and ethics. As software takes over critical systems, cars, hospitals, financial markets, someone has to be responsible. Someone has to ask, is this safe? Is this fair? What happens if it fails? AI doesn't take responsibility. Humans do. That means roles involving judgment, ethics, and decision-making are not going away. They're becoming more important. 4. Tool builders. Every generation of technology creates new layers of abstraction, and the people who build those layers capture the most value. Think about it. Framework creators, platform builders, infrastructure designers. They don't just use tools, they create them. And when you create the tools everyone else depends on, you're no longer replaceable. So where does this leave us? Software engineering isn't disappearing, it's evolving. It's becoming infrastructure, just like electricity, plumbing, or roads. And like those industries, the discovery phase is over. We already know how to build most things. Now it's about efficiency, scale, and maintenance. AI is accelerating this shift by automating routine tasks, writing boilerplate code, connecting APIs, generating templates, all the things that used to define the middle-class developer. And as those tasks disappear, so does the need for large numbers of average engineers. What remains are two extremes. At the bottom, people who struggle to keep up. At the top, people who understand deeply and think broadly. The winners of this new era are not the fastest coders. They are the people who can operate where things stop working. Systems architects, cross-domain engineers, problem solvers, people who don't just ask, "Can I build this?" but instead ask, "Why does this work? What happens if it fails? How does this connect to the real world?" Because coding was never the scarce skill. Understanding is. So here's the real question. Are you learning to use tools or to understand systems? Because in the future, that difference will define everything. If you found this valuable, subscribe, and I'll break down exactly how you can move from the middle to the top. See you in the next video.